So this talk will be about improving SmartArt import in LibreOffice itself. I'm Miklos Vajna of Collabora, and as you will see later, this is a collaboration between Collabora and SUSE. I started my LibreOffice activity as a GSOC student, then later worked for SUSE for a while and now at Collabora. Regarding SmartArt, the motivation for this work is that we already had basic support for importing SmartArt, typically from PPTX files, but it can appear in XLSX or DocX1. And the happy path as PowerPoint, newer PowerPoint typically writes not only the SmartArt, which is, we will see later, a definition of what your content is and what requirements you have on that content, how to lay that content out. But also there is a fallback, which is a pre-rendered drawing the markup of your SmartArt, and we can do a reasonably good job of importing that into Impress. But when that fallback, drawing the fallback is not there, then life is much more challenging. So we had a number of cases where the output was basically either nothing or some letters rendered on top of each other, and that's basically it. So for some cases we had terrible result, and this work is focusing on improving the rendering result in case there is no drawing gamma fallback. And it's still possible to show something sensible. It's just a matter of tracking down what part of the SmartArt description is not handled at import time and how to fix that. What's the missing implementation piece there? You could say that this is not a real issue. All of the newer PowerPoint versions write this drawing gamma fallback. But the problem is that there is a large corpus of legacy documents which are affected by this no drawing gamma fallback problem. And those, if you edit the document with newer PowerPoint versions, as long as you are not editing the SmartArt, this fallback won't be generated. Also, I like to believe that importing the SmartArt to Impress is just the first step. But it would be much more interesting later to actually allow editing of these SmartArts. And if editing is part of the game, then we definitely need to have this functionality to take the SmartArt markup and do our own layout. So that's basically why I think it's a good thing that this is improved. And as a next step, I would like to present a few SmartArt types which are now working much better. So the first thing will be the rendering of various list types. So for all of these examples, what you see on the left-hand side is the old LibreOffice rendering result, and what you see on the right-hand side is the new rendering result in Impress. For the vertical box list, the old rendering result was basically not readable. The new one is close to what PowerPoint would do. And then we had quite similar pre-canned SmartArt type in PowerPoint called vertical tab list. Again, the font color was not correct. Also, if you had enough content in the left column of the pictures or the shape, then that was not really readable. The new result is, in many cases, not perfect either. So the idea is that let's improve this up to the point that at least all the content is readable. If there is some interaction between the various shapes of this SmartArt, then it's clear what is the meaning of that relation, and don't spend like a year on just one type, rather make much more types readable and good enough so that we can move on to the next type and so on. So this is not perfect, but the hope is that for many types, this is now much more readable and much more usable compared to what it was. So a prime example of this is this line list where the lines are still not perfect, but this was just not readable before. And now we see that this is a lined list. Or in the vertical bracket list case, simply the content of the actual element on the right-hand side was completely missing. Or just improper sizing of these child shapes made that if you had enough content, that it was just not readable. Then we have the vertical table list, which was again something that where just the size of these child shapes was so incorrect that if you had enough content, that much of the content was simply cut off. So far about these various list types. Another bucket of various subtypes is the process types. And inside that, the first thing is the accent process. So again, just due to the incorrect calculation of these text shapes, in the previous case, the content was basically not readable, and now it's readable. I would also note that next to the text content, there also the bullets are no longer missing. And in case you had some more content inside a single text shape and you had multiple paragraphs with bullets, then the existence of these bullets is very, very important because that's the only visible separator between the separate paragraphs. So just remove the bullets and it's possible that the meaning of your content is just not something people can understand. So these bullets are very important. Then we have one more process type, this continuous block process, where again the size of the shape was just so small that if you had enough content, then the content was cut off. The last type I was recently working on is this organization chart, which is pretty complex. One metric to talk about the complexity of this chart is the number of XML lines that described all the constraints for laying out. And the previous ones are typically around 300, 400 lines. The organization chart markup is around 1,200 lines, something like this. So it's pretty complex. It just takes a lot of time to simplify these documents up to the point that they are simple enough that they are still interesting and it demonstrates the problem. On the other hand, the size is manageable, so actually you can efficiently debug them. So what you see on this picture is garbage on the left, as always, but on the right you see a strange organization with multiple managers where some of the managers have no employees, and this manager 2 has an assistant and also 3 different employees. And there are connector shapes between these two, so you have an idea how the organization is actually shaped. And this one was very interesting because this shape is constructed by basically 2 algorithms. One is one algorithm is focusing on how you lay out employees next to each other, so it's a vertical algorithm, and the other algorithm is focusing on how you lay out one unit, as in manager, optionally an assistant, and the employees. So it's a vertical algorithm. And not much of this is documented in the OXML spec. So your best bet is that you play around with PowerPoint. You get an idea of what's the possible intent. You simplify this huge markup to something sensible, 100 or 200 lines. You try to guess what's actually ignored during import. What's the reason you just get this garbage and not the readable chart, and you try to implement the algorithm in a way that it mostly behaves compared to what you see with black box last time. So far are the results, and for the rest, I would like to share some details about how this is implemented. So before any actual coding, I spent quite some time on trying to understand just the concepts around SmartArt, and I think this was the most challenging part, because inside the XML specification there is a reasonable description of individual XML elements, XML attributes, attribute values, but that's like the very small details. But there is no big picture overview in the spec. So getting an idea of what are the concepts behind this layout machinery is something that was the most challenging for me. So first, what we have is we have some data for the SmartArt, which is a hierarchical tree-like data structure with data points having parents and children and siblings. And we have the layout description. And the layout description is again a tree of what we call layout nodes. And this is what defines how the content will end up on the screen. That means that we have layout nodes for all the shapes which are visible on the screen, and also we have layout nodes for these containers. So if you have 3 shapes next to each other and you want to render them on a linear path, then you need a container that has an algorithm associated with it, and it should say that this should be laid out on a linear path. And then you need a layout node for this container as well. So everything is a layout node in this layout description. Then once you have the layout node, which are either shapes or containers or placeholders for just spacing between shapes and so on. So you have this layout building block called layout nodes. Then you can assign algorithms to these layout nodes, where the simplest algorithm is the shape, which means that this layout node should be mapped to a drawing-a-mouse shape, and the shape should get some data, some content from the data definition. We will see that in a moment. So you have your layout tree, layout nodes. Then you associate algorithms to these layout nodes, and you organize your layout nodes in a tree. And to make this much more interesting, the layout tree can have nodes which are called atoms, which allow dynamic behavior. So similar to accessibility, you can have conditions, for cycles, choices, and so on. So it's almost a whole programming language, which is a bit scary. So you can have let's say 2 layout nodes in a, 2 layout nodes in a layout tree. One is a root node and 1 children node or child node, and if you have a 4 layout atom between the 2, then according to your data model is dynamic how many actual shape ends up in the document. This is why you need some algorithm deciding how these multiple shapes are laid out. So we had the building block, the layout node, we had the algorithm, we had the layout tree. So data model mapping is the part that decides how the layout description is associated with the content you assign to the SmartArt. This means that typically when you edit your SmartArt on the user interface, then you only edit the data, and all these layout descriptions are hardwired into PowerPoint, and you can create your own custom layout description, but the majority of your users will just use this pre-made 100 types, or I did not count them. So there is a long list of pre-existing types, and users typically work with that. From our point of view, this is a very good news. We have a fixed set of layout descriptions, and of course we try to solve these layout differences in a generic way, but actually what users care about is really just this fixed set of layout descriptions, and if these are working, then users are typically happy. This is a bit easier problem compared to just handling random input for this layout algorithm and expecting that it's behaving exactly the same as PowerPoint all the time. So the data model mapping decides how to associate the layout nodes to 0, 1, or multiple data nodes. Finally, the last thing that really affects the shapes is that for layout nodes with the shape algorithm, you can associate shape properties. And again, this is tightly coupled to drawing gamma, so all the properties are using the drawing gamma markup. And later we will see this is why we don't do a direct import of SmartArt into Impress. Rather, first we take the drawing gamma input, we generate drawing gamma in-memory representation for that, and we use the existing drawing gamma import to actually map that to our shape model, because this way we can share a lot of code. What else? We have constraints. So this is the most complex part of that. You could even use an SAT solver to find out what's the optimal value for the various requirements to lay out these shapes properly. The good news is that so far this was not necessary. The current implementation is a one-pass layout, so we never position shapes multiple times, and so far this is even this much simpler approach is giving a reasonable result. So constraints are the ones which decide all the properties of all the layout nodes, like what should be the spacing between the shapes, what should be their size, their position, the font size of the content inside the shapes, and so on and so on and so on. If you use this automatic text sizing in Impress for normal shapes, then this is similar. It's just not a single setting which does something automatically, but a long list of properties, and all of these are calculated automatically. Next to constraints, there are rules. Rules are used for dealing with situations when you have conflicting requirements. So in case, for example, you give constraints that it's clear what should be the size of the shape, but then you have lots of content inside the shape, you have this conflicting requirement that on one hand you want to have all your content visible, on the other hand you have requirements for the size of the shape, so it should be, let's say, small. And then rules come into the picture, and rules can decide what happens when you have the conflicting requirement. For example, the rule might say that if there is not enough space inside the shape, then you should give up the constraint about the height of the shape, so it will be a very tall one, but at least your content is readable. Or you can decide that the conflict resolution should be that the font size should be decreased, so that it will be very hard to read, but at least all the content will be there. And the very last concept is the text properties. So next to the shape properties, you can define all the aspects of text as content appearing inside these shape nodes. Basically, these are the high-level concepts, and once you have a rough understanding what these mean, then it makes sense to jump to the reference and actually read about what the individual XML elements, attribute values are doing. So regarding the actual markup, this is all part of OXML with the same benefits and problems of the general OXML documentation. Sometimes something is reasonably documented, sometimes the documentation is completely opaque on the details. Inside the PPTX file, we typically have either 4 or 5 XML streams, like XML files inside this zip package. We have the data for the shape. Then we have this is the only piece which is actually edited by the users using the PowerPoint user interface typically. Then we have we can have shape styles which are specific to this SmartArt instance. This is defined in the quick style XML. This is typically not edited by the user. We can have color schemes. This is using almost the same markup as document themes. So this is again something that's typically not edited by the users. They just say that they want some dark color, let's say dark. And in practice, perhaps that will be dark blue, and then they want some text on that, so it should be text color, and it will be white, so that it's actually readable on dark blue. Then there is the layout XML. So this is the container for the constraints. This is the one that you read the most when you try to improve this code. And again, this is a fixed sound. So you choose that you want a vertical bracket list, and then you get a fixed layout, and whatever you do with your content, the layout definition is not changing. And optionally, there is this drawing stream, which is a pre-calculated drawing among group shape. And if it's there, then we can easily just import that into Impress. Yeah, so much about the markup. So speaking about how this is in the LibreOffice code base, all this SmartArt handling is inside the drawing ML import, and there is a subdirectory for diagrams, which is just the name for SmartArt. Probably SmartArt is some product name, and diagram is the alias used in the specification, but they are the same. At the moment, all of these layout is happening at PPTX import time or OXML import time. So if you want to test how this behaves, then you need to open a file and you will see the result, and you tweak the code, and again you re-import. So it's unlike writer layout where you open a document and you actually edit the document and see how the layout reacts to your keystrokes. This is an import time thing. And as mentioned, this is a two-step approach. So first we parse the SmartArt markup, and we produce a tree of these drawing ML shape objects. And then later we give this shape tree, drawing ML shape tree to the drawing ML importer, and that one will issue or invoke the necessary UNO calls so that the actual shape objects are created. So that's the high-level overview of the actual implementation. Then regarding how this is tested, the easiest way is integration tasks. So you load the document into Impress, and then you can use the UNO API to find out the various properties of the shapes. Given that this is import time, all the layout thing is actually part of the document model once the layout finished. So you can just use the UNO API, which would be available as macros, for macros as well, to assert the size, position, or content of the various shapes. Given that all the layouting is done with these containers around the shape nodes, there can be quite a deep hierarchy of group shapes. So the top container is always a group shape, but till you actually find the shape that has the text, it can happen that you have 5 or 4 group shapes inside each other till you actually reach your content. But the benefit of this is that there is more or less one-to-one mapping between the original layout tree and the resulting document model, and then you can reason about if this is a correct mapping or not. So this is somewhat helpful for debugging, and the users typically care about the resulting layout, so they probably want to ungroup all the group shapes in 4 or 5 stages. I have no numbers what was the state when I started working on this, but today we have almost 30 tasks, like 30 loaded documents with different SmartArt setups and loads of asserts. So when I start working on a new type, then add one test document for that type. Hopefully that's complex enough. And then as I incrementally try to improve the layout so that it produces something sane, then I keep adding new tests inside that single test function. So there are loads of ASRs compared to just the number of loaded documents. Hopefully that's a good trade-off between very long-running make check versus uncovered code. And the good news is that, again, this is filter work, at least technically, so you can do all your changes with the matching test coverage. So at least what was presented here as a result, all the improvements were in the form of commits doing behavior change and test change, no change without a matching test case. So that's basically it. Thanks to our partner SUSE, who sponsored part of this work. So this is why it was possible that I worked on this. And that mostly concludes my presentation. Thanks. Are there any questions? Yes, in the front row, Regina.
Is it correct that it is only about reading this SmartArt?
Yes, at the moment we read this, and if you write back to PPTX, then we actually remember the markup, so it's not lost. But editing at the moment is not possible. Although, as you saw from the architecture, the mapping from the SmartArt to actual shapes is a separate block. So in the future, if we have lots of time and motivation, it would be possible to move this from the PPTX import to actually Impress core. And then in the long run, this would also allow editing. But there are loads of problems to be solved first. But we are heading in that direction, yes. And another question in the back? The current state of the export is that if you just import your SmartArt and you save back to PPTX, then all this SmartArt markup is remembered, but you can't edit your shape and still preserve your SmartArt declarative description at the same time. I don't have numbers on that, and it's also an interesting question how you measure that. What I know is that I'm still aware of some problems which are interesting for SUSE, and we focus on our customers because that's how we get our paycheck. So I still plan to continue working on this, and let's see what will be the next step. Okay, thanks for listening again.